Hey guys, this is a video of properties of logarithms, but just examples, and we're going to be just expanding certain expressions using the properties of logarithms. So if you need a longer explanation of properties of logarithms, I do have a video on that. This is just going to be me plowing through more examples as I promised in another video. So I will drop a link to the just general explanation in the description. But otherwise, I'm going to be trying a different video format here, and I'm very curious to hear what you guys will think about this. So I have here the list of the 5 problems I'm actually going to cover in this video. And I've set this up so that you can either look in the description to just go to the ones that you want to see if you just want to fast forward. Or I've actually set it up so that you can see as you scrub through the video, as you kind of drag through, you should actually see the example letter pop up. So if you are looking in this list and you're saying oh, I want to see example D, you should be able to easily find that just as you scrub through. So I'm really curious to hear what you think about this format and if you think that I should make more videos like that. So maybe you could drop a comment if you found this helpful. Okay, so I will be doing these 4. If you want to use this as a quiz for yourself, that's actually a great thing to do with this video. You can pause the video, use it as a quiz, hit play when you're ready. And like I said, you will, as you kind of scrub through, you'll see that each example has been clearly labeled. Okay, so let's get to it. Okay, so starting with example A here. So this is just a very basic use of the properties of logarithms. So this will be just the straight up product rule, which means that I can break up everything in this expression with addition. So this will be log base 7 of 4, log base 7 of x, and log base 7 of y, and that would be it for that one. Okay. So moving on to B here. So one thing I discussed in one of my last videos was that one thing you can kind of rely on is that, so if you have something in the top, that will get a plus sign, anything in the bottom always gets a minus sign. So the way that this will break up then, I can break up the top parts. This will be log base 5 of 7 plus log base 5 of x minus log base 5 of w. So w is in the denominator, so it gets the minus sign. So that again is something you can kind of rely on. If you need more detail on that, consider watching my longer lecture video on the properties. So this might look almost identical to the last example we just did, but I promise you that it's not. So for this one, so if I break everything up, there's a little twist on this that I just wanted to point out here. So once again, I can break it up using a very similar format, but the one thing that makes this a little bit different is that this equals 1. So you do have to watch out for that when you're doing these types of problems. So that is going to be it for that one. So just watch out for when that property pops up from time to time. Okay, so moving on to this example. So now we're going to kind of combine everything that we've been talking about so far. So starting with kind of just breaking everything up. So once again, I can just say that everything anything in the top gets a plus sign. So this will be log base 3 of 27, log base 3 of the square root of x. And then anything in the denominator will get a minus sign. So this will be minus log base 3 of y to the 4th minus log base 3 of z squared. And now there's a few other things that we actually want to do with this. So first of all, we want to bring all of the exponents out in front of the logarithm. And then also 27, I want to rewrite 27 as in its exponential form. So what I mean is I'm going to rewrite this as log base 3 of 3 to the 3rd, which then allows me to use the power rule. So I'll use that in a moment. So maybe I'll just go ahead and write out the rest of these. I won't use the power rule on anything else yet. So I'll just do it all at once. Okay, so now what I'm going to do now that I've written this out is I'm going to take each exponent and I'm just going to put it in front of the logarithm. So what I get now is log base 3 times log base 3 of 3 plus 1/2 times log base 3 of x minus 4 times log base 3 of y minus 2 times log base 3 of z. And so pointing this out one more time, log base 3 of 3, this equals 1. So my final answer will be 3 plus log 1/2 log base 3 of x minus 4 times log base 3 of y minus 2 times log base 3 of z. And that'll be it for that one. And now for this final one. So this one's a little bit tricky. So notice that I've got this cube root kind of around the entire expression. So what I want to do first actually is I first got to just bring that power out. So that's really the only way I can start this. So I'm going to rewrite this as 1/3 times log base 5 of x squared over y. So now I've brought down that exponent, and now I can use kind of the rest of my rules. But remember, this 1/3 now has to apply to everything. So what I would recommend is that you expand this logarithm in parentheses and then distribute the 1/3 at the end. So if I go in steps, this will be log base 5 of x squared minus log base 5 of y. And then I can bring out the exponent down here. So this becomes 2 log base 5 of x minus log base 5 of y. And then I can distribute. So this becomes 2/3 log base 5 of x minus 1/3 log base 5 of y. And that covers all of the examples that I have in this set. So like I said, if you are looking for other videos, I do have others on logarithms. If you found this to be a helpful format, please let me know if I should try to make other videos like this, or if there's other examples that you want to see, feel free to ask. And otherwise, thanks for watching, guys.